All right. Well, welcome back to Energy Explained, our family YouTube channel. And I'm here with my father, as we always do, Vikram Rao, who comes to us via Stanford's PhD in engineering program. And he's a former CTO of Halliburton. He certainly speaks with authority on all matters energy. And today we're going to talk about steel and talk about how steel is used in infrastructure, but also how the environmental consequences of steel are actually quite high. But before we jump into steel, we were just sort of joking around. NCAA championship. The women's side, I'm sure you're happy with Stanford winning, being from a Stanford alum. How are you feeling about the Stanford women taking the crown?
Well, it was a squeaker. When you win by 1 point, when their star player throws up a shot and it doesn't go in, yeah, it's a win, but it's a squeaker.
Well,
Uh,
when they hang the banner up, they don't put the score. So I wouldn't necessarily worry about that. So next time, what is it? Poly Pavilion? No, it's UCLA. What's Stanford's?
yeah, no, Stanford is Maples Pavilion. Yeah,
Maple. Next time you're in
yeah.
Maples Pavilion, you look at the banner, sit there with pride that the score won't be up there. But yeah, it's a 1 point
I
win.
think it's great, and I'm really happy for Vanderweer, the coach, because she's been at it for a while, and more than anyone else actually. And there have been some great Stanford players who've gone through, who just never hung up the banner, and
Yep.
so this one is really for all of them, is what
Yep.
it comes down to.
And
Yeah.
the NCAA Women's Final Four featured two African American coaches, which is the first time ever, which is also fantastic to see. So the women's bracket really bringing, not getting as much attention, but certainly near and dear to our hearts. I know we're big fans of women's basketball, so
Yep.
good to see. Now in a good mood setting, we're jumping into green steel. Now we were just talking about, in the pre-call, what people I think really struggle to understand is where does greenhouse emissions come from? And what we'll do is start with a simple breakdown. Now, the facts and figures out there vary by the sources you look at, but all the sources we've looked at agree on three basic facts. One, three-quarters of greenhouse gas emissions come from the production of energy. The rest is agriculture, disposal of waste, and so forth. Of that big energy component, in fact, the largest producer of greenhouse activity is industry. The second is use of energy to cool and heat buildings. The third is transportation. And within transportation, car-based and based transportation, so road transportation, actually constitutes about 11%. When you add up steel and concrete, you get to 15%. So steel and concrete are more than cars. Yet we hear a lot about electric cars in Biden's recent infrastructure bill. Electric cars had a huge component, a huge subsidy. We're not hearing much about what's actually bigger than all of ground transportation, including trucks, let alone electric cars. Let's talk about that. How is there so much greenhouse gas produced via the production of steel?
Yeah, well, first of all, let me say that that's been flying under the radar a bit too much. I mean, the Biden plan on infrastructure build, uh, one must appreciate the fact that when you build infrastructure, a lot of steel and concrete
Right,
gets used.
right.
I mean, just almost disproportional.
Yeah.
Uh, so when you're talking a massive infrastructure build, figure on a massive greenhouse gas eruption. Okay, so so that may alone be the reason to attack it. Now, clearly, the administration sees that and went after subsidies in electric cars and so forth. But they need to recognize what you just said, that that sort of transportation does not account for as much greenhouse gases as steel and concrete, and steel and concrete are directly proportional to the infrastructure build, whereas transportation kind of is, if you build more roads, then more people will travel. Okay, got it. Okay.
Sure.
Uh, but when you build the roads and the bridges, you use steel and concrete. So going back to your question, I guess your question was, how is it that,
Well, how much is produced? When you produce a ton of steel, how much CO2 do you get and why?
okay, so this is going to surprise people. Each ton of steel produces 1.8 tons of carbon dioxide. Uh, Huge, nearly
Just
2 tons
staggering.
of carbon.
Yeah, that's a staggering amount.
Staggering.
Yeah.
It's staggering. Uh, and the reason it happens is sort of a quick tutorial. Is most in the iron making process. So steel is just iron with the carbon reduced to a certain degree and certain alloys added. Okay,
Okay.
but not going into
I'm going to
much depth.
pretend I kind of understand what you're saying, but I'm just going to trust that it makes iron better. I don't really
Exactly.
get. Okay. Yeah.
Make iron stronger or
Yeah.
stand resistant or
Yeah.
whatever. Uh, uh, so the main manufacture of steel is something called blast furnaces, and so the what is used as the reducing agent. So what is iron ore? It's iron oxide. We need to get it down to iron metals. We need to take the oxygen out.
Yep.
The oxygen is taken out using coke.
Yeah.
Coke is a coal derivative.
Yeah.
That's the way it's done. So that is where you get the CO2. The majority, it is simply because coke is used as a reducing agent, and it produces that much.
Yeah.
That's the basis of it.
Okay. So we're now at a point where we understand that the production of actually just steel alone is really proportional to all of consumer ground transport. So all of the cars in the world and all of the steel production in the world are a commensurate amount of greenhouse gas emissions. This is our understanding to this point. Now, we know about electric cars. We've talked about electric cars. It's clearly not a panacea, but why, in your opinion, has steel and concrete also not really gotten frontline billing? We've also heard about going vegetarian due to bovine gas emissions, all of this stuff. I have never heard about steel being this important in greenhouse gas emissions. Why do you think that is?
Actually, I don't really know. It's partly because the other things are sort of more consumer things.
Like I can do something
And
about it. Like I can go buy a Tesla or a Honda or whatever.
I can personally do something about it. The same goes with insulation in the homes. I can do something about
Right.
it. Reduce the thermostat. I can do something. On electricity production, I can't do something, but I can be an activist and say get rid of coal
Yeah.
or get renewables in. I think that this maybe it's simply because the public doesn't know.
Yeah.
Okay.
Okay.
It flat out is that.
Yeah.
If public becomes aware of this, that steel plus concrete add up to more than transportation, I guarantee you the man on the street is going to say, what? You got to be kidding me.
No. Airplanes are 1.8% of the total. Steel and concrete are 11 to 15%. I think people will be shocked to learn that fact. So now let's say that fact, okay, it's not as widely known as it should be. And let's imagine a case where there's some public demand for cleaning this up. Now, there was a pretty prominent New York Times article written recently on this, a major steel manufacturer investing in technologies to make their steel more green. Now, could you comment and just sort of briefly overview what those technologies are and how optimistic you are about those technologies really making a meaningful impact?
Yeah, so 5 years ago, I would have told you that about the only way to get steel makers to go green is for them to buy carbon credits.
Okay.
Okay, and that somebody else would have to do something, build forests or whatever.
Yeah.
Okay. Now that's not the case.
Interesting.
Yes, it's definitely not the case. So in the case of steel and concrete are different in the solutions. But there's one solution which is just hitting the ground running, which applies to both, and that is carbon capture.
Okay.
So for a company, the decision on whether to capture the CO2 or whether to pay the credit is economic. All right. So if you can capture it for under what the cost is, then you'd probably just do it.
Yeah.
Aside from being a good guy. Okay.
Yeah.
So because if the major industry, the major polluter, if you will, does nothing and simply buys credits, at some point that gives. Okay.
Well, it's supply and demand. The price of a credit will be driven up by the increased demand for those credits. And for a small sector of the economy, sure, airplanes, for example, I think we discussed it previously. There's no really known technologies to get a plane in the air without using hydrocarbons. It's 1.8% of the total. It might be realistic to completely offset all of air traffic via building forests. But when we're talking about 15% of the total, you start running out of that option, right? You start sort of hitting the supply wall there. So you really, in your opinion, you say, well, no, it's kind of got to be at the point source here.
Yes. So, and so then the question is it feasible? In fact, in the case of steel, their clients are asking for it. That New York Times story you mentioned says that this European client is prepared to pay 10% more for green steel. So these people in the story, ArcelorMittal, which is the #1 producer of steel in the world, are committed to going green. So the question is, can they?
Yeah.
And so the story shows a couple of things. No disrespect to those couple of things, but in my opinion, the solution comes in two different areas. One is there is a there's a process of iron making called direct reduction iron. Let's not go into it. Let me just say this. That process produces one third the CO2 as the regular process.
Okay.
Yes, one
Yeah.
third. So only 0.6 tons
Yeah.
of CO2 per ton of steel. So then why doesn't everyone do it? People are doing it, but only 7% of steel production is from that source. Why? The reason is that particular process requires something called high grade iron. There's
Oh,
not much.
okay.
Yes, there's not much of it. So there are all these things. You can have a technology, but it may have a limitation. But the part that I'm leaning towards right now is straight capture.
Yep.
And I'm here to tell you that the technology is there. It is currently in large scale, about to go to large scale. So, but I'm putting my reputation behind the statement that the technology is there to get CO2 out for under US dollar 40. So under 40 US dollar, about
Okay.
40 US.
Okay. And market prices right now are a bit higher than that, right? And so it depends
Yeah,
on
so
where you
Europe
are,
it's
and it depends on how,
45 euros.
right?
Yeah, it's 45 euros in which is about 55
$55.
dollars.
Yeah.
Yeah, in Europe right now.
Now, what's capture
And
technology? So is that, like, is that sort of at the tailpipe and you're literally cleaning the air that goes up into the atmosphere? Is that what it is? You do the exact same process, but you just kind of clean the tailpipe. It's like a catalytic converter, a muffler for your plant.
yeah, that's a good point. Actually, tailpipe capture can be done, but we won't go there. It's not economically
Sure.
feasible for couple. But no, this is industrial capture. This is on the top end of the blast furnace or the back end of a power plant. Okay, yeah, the gases go through something through a processing equipment, and the CO2 is captured in a solution. It's called an amine solution, but or it could anyway. It doesn't matter
Yeah.
the chemistry. The point is captured and then released later.
Yeah.
But when it's released later, it's pure CO2, and you can do something with it.
As in, you put it in bottles and use it to something, or you bury it, or you affix it to something. That kind of idea.
Yeah, so my favorite for that is it's called mineralization.
Okay.
Uh, uh, you turn it into a carbonate, and so mineralization of concrete is something that's possible. But in general, mineralization means turning it into a very stable compound.
And now,
That's the
when you talk about $40, which is a really attractive price, is that including the cost to mineralize it, or is that assuming advances in mineralization?
aha. No, it is just the capture cost. It, so I think of this problem as sources and sinks,
Mm-hmm.
like snakes and
Mm-hmm.
ladders. Something.
It's a good
So the
tagline.
source, yeah, the source is the where you got it. Having it in your hand does no good unless
No,
you can put it away.
right? Because you just let it go again and bye bye, whatever. Like,
You got it. So you need sinks.
yeah.
That's going on right now.
Okay.
So the mineralization sinks, this work going on. I'm personally directly involved in one of them, and it's really cool. So mineralization will happen, or something else, some other conversion of CO2 into something useful. You talked about carbonated beverages. Yeah, it's fun, but it's a very small amount, as
I
you well
was
know.
almost kidding. My knowledge of chemistry is borderline to be qualified to have this discussion. So I was almost kidding, but I do realize that it would actually
Yeah.
do something better than releasing it. But okay, so you're asserting, and you said you're staking your reputation on it, which is a bold statement, that instead of focusing on idiosyncratic steel specific solutions, you would say no, focus on what we have a more mature technologies in, which is capture, and then mineralization, or the sink, which is turning it into a solid and putting it in a hole in the ground, basically, is almost literally what you're doing. Those general purpose technologies, you believe cost wise, so you're saying if there was a carbon tax of $70 per ton, then everyone would have the incentive to go figure this out. And in certain places in the world there is, and then you'll see the development there. I believe you did quote European steel buyers were the leading edge of that demand pattern because they're being held accountable internally and how they produce stuff. So with those numbers, you really believe that we can greenify steel. Now, interestingly, and this comes back to this public perception issue, the public really views electric cars as a huge solution, but this is a bigger deal. How do we raise awareness in your mind over the importance of these issues? Because you actually believe, for example, what you are really claiming, and it's quite bold, there might be much more to gain from cleaning up steel than there is cleaning up transport.
Yeah, and steel and cement together.
Steel and cement together.
Yeah, and before I answer that, let me make a small modification to one thing you said. Yes, I think the avenue is capture the CO2 and do something with it. But I'm not discounting techniques for improving the steelmaking process
Okay.
to be green. Yeah, because in fact, there are certain avenues that I personally think one should take. So it should be both. It should be all of the above kind of thing.
Okay. But your belief is those techniques are amenable to certain forms of the ore or certain conditions. And if those conditions aren't met, and at large scale right now, you don't see those conditions being met in the near future, but you do see near to medium term solutions in carbon capture, a fixation, and getting rid of it that way. Thus, you're much more sanguine on the capture piece. And it's the similar technology for concrete, steel, and even electricity generation and coal power plants, right? It's similar technology. So it's a more of a general purpose technology. Would you want to see, as a former energy executive, as an expert, would you want to see public investment in carbon capture technology?
Yeah, so I think that the awareness raising can happen in one of two ways or both ways. One is that federal governments can say, we recognize the problem, and by golly, we will help it with X, Y, Z. Okay, low interest loans or whatever, the kinds of things that they've done.
Capital improvement loans to clean up your act, and I give you the loans today, and over 30 years you pay it back, and it all works out for society. There's capital constrained industries and firms. Federal government solves a liquidity problem. That's a huge, it actually doesn't cost you much because they repay the loan or it's interest-free loan, et cetera, right? So there's that. You say that's a no-brainer.
Yep. And so that'll draw attention to it. Okay. The other thing is that this steel industry itself and the concrete industry should step up and say, we're doing this. And here, apparently ArcelorMittal has done. They gave New York Times their story. Okay.
Right. Yes, of course. That's from their PR department, almost surely.
Exactly. So I think the awareness can be raised because it would really help them also if more of their clients did what that one client did.
Yes, they have the demand. It comes from the demand.
See, it's like, in the last discussion we had, remember you mentioned that people can buy green electricity, okay?
Yeah.
They can choose to do so, pay a little bit more, okay? Well, by golly, that'll be the same for green steel or green cement, okay? In fact, the federal government should probably say that in the infrastructure build, they will preferentially give contracts to green steel and green concrete. Boom.
Yeah.
And no price difference at this point, or they could choose to give it a price difference, which is in effect a subsidy. Okay. But that's what they're doing with electric vehicles, a subsidy.
Yeah.
So I would advocate, in fact, I'm making it up as I'm going along.
Well, that's what we do here. Yeah, that's what we always do.
that on infrastructure build out, that the federal government, this is the U.S. federal government, probably others too, should say that they will favor green, and they will have defined that, of course, as to what is meant by green steel and green concrete, and they would favor it and perhaps give a higher price. Yeah, these are the kinds of things that will move the needle.
Yeah.
Okay.
Yeah, it's interesting, and one of the themes of this channel as we get in is that the public attention and the policy seem to be highly aligned, but not always aligned to the technological capabilities and the actual impact. And I think we've identified an area here. Now we're at our sort of self-imposed, people don't want to listen to us more than 19 minutes time limit. So I think if you're comfortable with all the points we've made, I see you smiling. We'll remind everyone, look, if you like the content, hit subscribe. We love doing that. We're also available on your favorite podcasting platforms at this point. If you want to listen to us in the car, we're on Spotify, we're on Google Play, we're on most of them out there right now. So go ahead and look for Energy Explained there. It's the same name. And until next time, keep the comments coming, keep the feedback coming. We had some requests to talk about nuclear power, where we have that one lined up as well for the future. We love the engagement. Continue on. Thanks for all the support. We're signing off for now. Have a good week.